recording. And good morning again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, so I have a couple of things I want to remind you of. One of them has to do with people that email me requests to do problems during class, and that's great. I want you to do that. But I want you to do it like by 9 o'clock the morning of, or the night before, the morning of, but not at the last minute. This morning, I'm frantically writing down everybody's thing and people are still sending me emails at 10 o'clock. I really need to get those like by 9 in the morning if you can. That just helps me to get ready in time. Secondly, I've still got people that aren't sure what my expectations are on tests in terms of work, okay? So let me tell you again, and this should be back on the testing policy that you all read, supposedly, and agreed to. It basically says, when you're taking the test, you're gonna write all your work down on scratch paper, okay? When you get an answer, you're gonna submit it. If it's the correct answer, great. If it's the wrong answer, but you want to try and get partial credit for that problem, take a picture, scan, whatever, of the scratch paper and email it to me. But I don't want you to sit there and rework the problem 18 times and then send me the work with the right answer. I want the work that you did that led to the wrong answer, so I can see what part of the process you're understanding and what part you're not understanding. People are still going through and reworking it and submitting the right answers working. I'm not even gonna look at that. That's not what I'm asking for. I'm just looking for, is there partial credit I can give you? You had some understanding. And I also want you to send that to me right after the test, not like 2 days later. Okay, anyway, we now have some questions that people requested. So I'm gonna look at those. And then we'll get on to section 7.4 here eventually. So these are questions from yesterday. Let's see. This is from 7.3. Okay, and this is number 32 to start with. It says, build the following rational expression into an equivalent expression with the given denominator. All right, and we have x plus 7 over 3x minus 15. And the given denominator is 3 times x minus 5 times x plus 11. Okay, so that original fraction is x plus 7 over, and we could factor the denominator into 3 times x minus 5. I want to create a new fraction whose denominator is 3 times x minus 5 times x plus 11. So the missing piece that I need to multiply the denominator by is x plus 11, which means I also need to multiply the numerator by x plus 11. So then my new numerator is going to become x squared plus 7x plus 11x plus 77, or combining like terms, x squared plus 18x plus 77 over 3 times x minus 5 times x plus 11. Okay. So I had to find the missing factor for the denominator, also multiply the numerator by it, FOIL them together, combine like terms, final answer. Any questions about that particular problem? Are we good to go on to the next one yet? Okay. Same assignment, problem number 33, same directions. Build the following rational expression into an equivalent fraction with a given denominator. And our original expression is y plus 8 over y squared minus 10y plus 16. And the new denominator is to be 5y times y minus 2 times y minus 8. All right, if I take my original fraction, I get y plus 8. The denominator would be y and minus 8 and minus 2. And I need to turn that into a new fraction that has a denominator of 5y times y minus 2 times y minus 8. So what's missing in the old denominator that's in the new denominator? 5y. So I multiply the denominator by 5y, which means I also have to multiply the numerator by 5y. So then my new numerator becomes 5y squared plus 40y, and there's my final answer. Let's see, we've got one more here for this person. We good to go on to the next one? Okay, this is number 34. Same directions again, build the following rational expression into an equivalent expression with a given denominator. 15 minus h over h squared minus 49. And the new denominator is 6 times h plus 7 times h minus 7. So I'm going to rewrite the original fraction, 15 minus h over h squared minus 49 is the difference of two squares, h plus 7, h minus 7. And I want my new denominator to be 6 times h plus 7 times h minus 7. So what I'm missing is a 6. So I'm going to multiply the denominator by a 6 and the numerator by a 6. So now my new numerator becomes 90 minus 6h. And there is my final answer on that one. Okay, let's see here. That takes me back here. 1 and there. 7.3. Starting with number 16. Okay, are we good to go on? All right. We're still in 7.3. This is another person's problems. We've got number 16 to begin with. It says subtract and simplify the result if possible. And our subtraction situation is 6x squared over 3x plus 2 minus the quantity 11x plus 10 over 3x plus 2. So I'm subtracting two fractions with the same denominator. Okay, so I'm going to get 6x squared minus the quantity 11x plus 10 all over the common denominator, which is going to give me 6x squared minus 11x minus 10 over 3x plus 2. Now, I'm going to introduce something that I haven't talked about before. And actually, let me do this. I'm going to do it the long way, and then I'm going to come back and do it the short way. So now what I need to do is I need to factor 6x squared minus 11x minus 10. Okay, so let's take that 6x squared minus 11x minus 10. Okay, I'm going to factor it using grouping. A is 6, B is negative 11, C is negative 10, the product is negative 60, the sum is negative 11. How about, let's see, well, negative 60 and 1, negative 30 and 2, negative 15, negative 15 and 4. So this is going to be 6x squared minus 15x minus or plus 4x minus 10. By grouping, we're going to get 3x, 2x minus 5 plus 2, 2x minus 5. So we're going to get 2x minus 5 times 3x plus 2. Okay, 2x minus 5 times 3x plus 2. So 2x minus 5 times 3x plus 2 over 3x plus 2. So I factored that into that. Oh, now I see there is a common factor of 3x plus 2 that I can reduce out. So my final answer is 2x minus 5. Okay with that? All right, now I want to talk about a shortcut, if you will. And so what I want to do, I'm going to take this problem and write that out again. 6x squared minus 11x minus 10 all over 3x plus 2. Now, consider this. In fact, let's come back to that. Let's say I've got 15 over 3. Can I reduce that?
Yeah.
How do you know I can reduce it?
Just 3 goes into 15.
Oh, so 3 goes into 15 and obviously goes into itself, right? Okay. Can I reduce that?
No.
Why not?
Because 5 doesn't go into 17.
So for something to reduce, it has to have a common factor in the numerator and the denominator, right? How about this? 8 over 25. Does that reduce?
No.
The numerator is made up of 2's and the denominator is made up of 5's. No common factors, they don't reduce. So again, for a fraction to reduce, it has to have a common factor in the numerator and the denominator, right?
Correct.
Okay, now let's take a look at this problem. If this is going to reduce or simplify, it would have to have a common factor in the numerator and the denominator, right?
Yeah.
There's only one factor in the denominator. So for this to reduce, what would one of the factors of the numerator have to be?
4, 6, right?
3x plus 2.
Bingo, 3x plus 2. So let's find out if it is. Well, let's see. How would I get 6x squared? 3x times 2x. How would I get minus 10? Plus 2 times minus 5. Does that give me minus 11x in the middle? It sure does. There's minus 15x plus 4x. Bada boom, bada bing, and we're done. See what happened there? What if it hadn't worked? Well, if 3x plus 2 isn't a factor of the numerator, this thing isn't going to reduce, and it doesn't matter whether we factor it or not. It's not going to reduce. Okay? Let me give you one more example. Let's say I have 4,532 divided by 17. Okay? Now, I want to know if this reduces. One of the ways I could check is to take 4,532 and break it down into all its prime factors and see if 17 shows up. Or I could just see if 17 shows up, right? Take 4532 divided by 17, and if it shows up as a factor, great, we're done. Same thing here. I don't need to factor it unless this is a factor of it. So just start out with that and see if you can make it work. Now, if that confuses you, go back to doing it the long way. But if it makes sense to you, you can save some time that you'll have to watch Gilligan's Island reruns or something. Okay, moving on. Number, let's see here, 18. I just wanted to put that out there for you if you want to take advantage of that. It says subtract and simplify the results. You've got 8 minus 4p over p squared minus p minus the quantity negative 4p plus 8 over p squared minus p. So subtracting two fractions with the same denominator, we've got 8 minus 4p minus the quantity negative 4p plus 8 all over p squared minus p. Okay, we're subtracting the entire second numerator, which is 8 minus 4p plus 4p minus 8 over p squared minus p, which is 0 over p squared minus p, which is just 0 because those cancel and those cancel. So we've got 0 over p squared minus p, which is 0. That takes us to problem number 41. Okay, we good to go on?
Yeah.
All right, number 41. It says, perform the operation, then simplify if possible. We have 5r minus 27 over 3r squared minus 9r plus 4r over 3r squared minus 9r. So we're adding two fractions with the same denominator. We're going to add the numerators, 5r minus 27 plus 4r over the common denominator. Simplifying the numerator, combining like terms, I get 9r minus 27 over 3r squared minus 9r. Okay, so now I've simplified the numerator and the denominator, but let's see if we can reduce this fraction. I can factor a 9 out of the numerator, and I can factor a 3r out of the denominator. In doing so, I can now reduce out the common factors of r minus 3, and I can reduce 9 over 3 to 3 over 1, and I'm left with 3 over r as my final answer. Okay. Last problem, number 44. Okay, and this is part B. It says x over 9 times 2x over 9. Okay, interesting thing here, because I'm looking at what the student did, not to pick on you at all, but just to see what they did. They got the denominator correct, which is 81, but they added the numerators. They took x plus 2x to get 3x, okay? So we're multiplying. So on the bottom, 9 times 9 is 81, but on the top, x times 2x would be 2x squared. If it was x plus 2x, that would be 3x, but x times 2x is 2x squared. You got to be really careful there with all the operations. Okay, that was all the requests that I got. Unless any of you have anything right now you want to look at before we go on to the new section. Now is the time to speak. Okay, then we shall go on and take a look at section 7.4, which is adding and subtracting fractions or rational expressions with unlike denominators. Okay, let's do a review of how that works. Let's say we have y divided by 4 plus 3y divided by 5. So now we're trying to add two fractions that don't yet have the same least common denominator. So the first thing we need to do is to determine the least common denominator. In this case, it should be fairly simple. What's the LCD of 4 and 5? Anybody?
20.
20. Excellent. So what we need to do next, we need to take each of our original fractions and we need to write them as new fractions that have the least common denominator. Okay, this was one of the things they had us do Was it yesterday or 2 days ago? Yesterday's assignment. Okay. So what am I going to multiply the 4 by to turn it into a 20?
5.
5. Since I multiplied the denominator by 5, I also multiply the numerator by 5. 5 over 5 is just 1. So technically, I'm just taking y over 4 and multiplying it by 1. And it becomes 5y over 20. So we took y over 4 and made it into a larger fraction that had the least common denominator. Any question about what just happened there? All right. Next, 3y over 5. What do I need to multiply the 5 in the denominator by to turn it into a 20?
5.
4.
What was that?
We'll multiply both sides by 5. So you will
No,
multiply it.
not 5.
4.
4.
Yes.
You see it? Giovanni?
Yeah, I got it. My bad.
Okay, okay, all right. That's all right. So this becomes 12y. So now we have two fractions with the same denominator. So we're going to add the numerators over the common denominator, 17y over 20. Now, if we can reduce it, we will. This particular problem doesn't reduce. So there's our final answer. So what did we do? We found the least common denominator of both fractions. We built both fractions up to new fractions that had the least common denominator. Then we added the numerators over the common denominator and reduced if we could. In this case, we couldn't, so we didn't. All right. Now, the problems are going to get more complex, but the idea in terms of the steps is going to be the same. Find the LCD, build fractions to where they have the LCD, combine the numerators, reduce if possible. Okay, here we go. 6 over n squared minus 2 over n. So what is the LCD of n squared and n?
N squared.
N squared. If it ain't broke, don't fix it. So the first fraction already has the LCD, so we don't need to change anything there. What do I need to multiply the denominator of the second fraction by to turn n into n squared?
N.
So if I multiply the denominator by n, I must also multiply the numerator by n, and the new numerator becomes 2n. So now I have my two fractions with the same denominator. I'm going to subtract the numerators, 6 minus 2n over n squared. Can I reduce it? I see that I could factor a 2 out of the numerator. However, doing that doesn't produce any factors that are reducible. So this answer's okay, this answer's okay. This was to see if it had anything in common to reduce, and since it doesn't, I'm just going to go back to that, but either one should be acceptable. If WebAssign doesn't like this, then give them that, I guess. I don't know, we'll see. All right, any question about that?
Nope.
Okay. Let's see here. 15 over 16a minus 3 over 4a squared. Let's see, our denominators are 16a and 4a squared. 16 is 4 times 4, which is 2 times 2 times 2 times 2. So I've got 2 to the 4th times a. 4 is 2 times 2, so I've got 2 squared times a squared. So the first denominator prime factors out into 2 to the 4th times a. The second denominator prime factors into 2 squared times a squared. So my LCD, I would need 2 to the 4th times a squared. The highest power of 2 times the highest power of a, or 16a squared. Now, You might have been able to look at the original problems and done that, but I just wanted to review that process of how you find it if you can't just see it. So now I've got 16a, let's see if I can write that a little nicer. 16a squared and 16a squared. What do I need here to turn 16a into 16a squared?
A.
Are you Canadian? A? Yes. And so my new numerator becomes 15a. What do I need here to turn 4a squared into 16a squared?
4.
So my new numerator becomes 12. The fun part is to say new numerator. The simple life I lead. I have to get all the pleasure I can from the small things in life. All right. So now we've got 15a minus 12 over 16a squared. I can factor a 3 out of the numerator and get that. However, once again, that doesn't produce any common factors. Sooner or later, we'll find one that does. So this would be my final answer. But I encourage you to take it that next step and make sure there's nothing, or that there is something you can reduce out. Okay. All righty. Let's take a look. Are we good to go on?
Yeah.
Yep. All right, let's take a look at this one. 9 divided by b squared minus 2b plus 1 minus 2 over b minus 1. I'm going to factor the denominator of that first fraction because I see that it is that. Okay. So what is the least common denominator of the two fractions?
-1 squared.
Yeah, b minus 1, the quantity squared, or you could say b minus 1 times b minus 1, either way. Tell you what, I'll just leave it written out this way, but you could also write it b minus 1, the quantity squared. So once again, if it ain't broke, don't fix it. Here, what do I need there to make the denominator b minus 1 times b minus 1? What am I missing?
The b minus 1.
Right. So the numerator and the denominator both get multiplied by b minus 1, and I'm going to get what? 2b minus 2. Okay.
Mm-hmm.
So now I've got two fractions with the same denominator. I'm going to take the numerator of the first one minus the entire numerator of the second one, all over the least common denominator. I'm going to distribute the subtraction sign, 9 minus 2b plus 2 over b minus 1 times b minus 1, which gives me negative 2b plus 11 over b minus 1. And I'm going to go ahead and write it this way this time because I'm feeling lazy. Now, minus 2b plus 11 doesn't simplify any further, okay? So I can't get any common factors out of it, okay? Any questions about that one?
No.
All righty. Well, let's pull out the big guns. Here we go. Okay. Hopefully I can get this all on one page. Let's say I've got d over d squared plus 6d plus 5 minus 3 over d squared plus 5d plus 4. To find the least common denominator, I'm going to factor each of the original denominators. So I have 5 over d plus 5 times d plus 1 minus 3 over d plus 4 times d plus 1. So what is my LCD going to contain?
D plus 5, D plus 1, and D plus 4.
Excellent. So down here, D plus 5, D plus 1, D plus 4, D plus 5, D plus 1, D plus 4. What do I need here?
D plus 4.
D plus 4. So I also need D plus 4 up there, which means I'm going to get 5D plus 20 for my new numerator of the first fraction. What do I need down there?
D plus 5.
So I'm also going to multiply the numerator by D plus 5, which means my new numerator is going to be 3D plus 15. So now I have two fractions with the same common denominator. Are we good to
Wait.
keep going?
I have a question.
Yes.
So for the first one that you wrote, you put D minus 3. And then for the second one, you have 5 minus 3.
Say that again. I'm not finding where you're talking about.
On my screen, it shows like a 5 or a D over D squared plus 6D plus 5 minus 3D squared plus 5D plus 4. But then you wrote 5.
Oh. Yes, I see that. Thank you. Thank you. Yes. I made a mistake.
Okay.
Yeah. Thank you. So this is supposed to be a D. I'm glad you pointed that out now and not later.
Yeah,
Okay. D squared plus 4D. Yes. My D morphed into a 5. I can't read my own writing. Thank you so much, Sarah.
You're
Oh,
welcome.
or excuse me, SB. All right. So now we're going to have D squared plus 4D minus the quantity 3D plus 15 all over the LCD, okay? I don't need the LCD yet, so I'm not going to write it. I'm just going to leave it as LCD for the moment, okay? When I need it, I'll bring it back in. So that's going to give me D squared plus 4D minus 3D minus 15 over the LCD. Okay, I'm going to take this and I'm going to copy it on the next page. So I've got D squared plus 4D minus 3D minus 15 over the LCD. Okay, which is D squared plus D minus 15 over the LCD. Okay. Now, can I factor D squared plus D minus 15? Let's see if I could do that. We'd have to have a product that was negative 15 and a sum that's 1. That doesn't factor. So my final answer, now I'm going to bring back that, what is it, plus 4 plus 5 plus 1? D plus 4, D plus 5, D plus 1. And there is my final answer. Okay. Yeah. And again, thank you for correcting my mistake. Please do if you see them. All right. Let's take a look at another example. Nine n over m plus 4 plus n. So what is the implied denominator of the second fraction?
1.
Right, so there's an implied 1 there. Good. So what's the LCD?
M plus 4.
Yeah, just m plus 4. So the first fraction is fine. The second fraction, we're going to have to multiply the bottom by m plus 4 and the top by m plus 4, which means we get mn plus 4n. Let's make sure I got my m's and my n straight. See, now I'm nervous after changing that d to a 5. I'm like, I don't know. Don't trust myself. Okay. So now we're going to have 9n plus mn plus 4n over m plus 4, which is what, 13n plus mn over m plus 4. Now, I can factor an n out of the numerator and have 13 plus m left over, but that doesn't accomplish anything. So this is just fine as a final answer, and so is that. Again, I don't know if WebAssign will want it factored or multiplied out. You'll try one. If it doesn't work, you'll try the other. Okay with that?
Yeah.
Right. Now, take a look at, let's see here. One over x minus 7 minus x over 7 minus x. Now, looking at it initially, we might think, oh, the least common denominator is all that x minus 7 times 7 minus x, this big thing, and we build this massive, horrible thing we have to deal with. But what's the name of that movie, The Secret of Dogs and Cats? Isn't there a movie called that? This is all about doggies and kitties, okay? Look at those two. Those aren't the same, but they're opposites of one another. So what we could do is we could come in here. I'm going to take the first one and leave it alone because it's in standard form, okay? I'm going to take the second one and I'm going to multiply it by -1 over -1. Now, why do I want to do that? Because 7 minus x is the opposite of x minus 7. If I take a number times -1, it's going to turn into that other number. So watch carefully, okay? So on top, I've got -x. On the bottom, I've got -7 plus x. Okay? You see where I got that?
Yeah.
But that's the same thing as 1 over x. Whoops. Hang on. Slow down here. Minus -x. Isn't that the same thing as x minus 7?
Yeah.
Now, that seems a little complicated, but it's still going to be nicer than if we take everything on the left side and multiply it by x, or 7 minus x, and everything on the right side and multiply it by x minus 7. We create this big mess. We don't want to do that. Okay? So now what have I got? I've got 1 minus -x over x minus 7. Subtracting a negative is like adding a positive. So I've got 1 plus x. I'm going to write that in descending powers. So I've got x plus 1 over x minus 7. Maybe. Okay with that?
Yep.
So by multiplying by -1 over -1, I had the opposite of the top and the opposite of the bottom. But now this ultimately, it matches that. And even though it may look complicated, it's still easier than going the other way. Okay. Let's see here. Let's redo this. Let's take 5 over 2x plus 4x over 15. And then let's do 5 over 2x times 4x over 15. The author calls these lookalikes. Same numbers, different operation. When you're adding or subtracting fractions, you need a common denominator. When you're multiplying or dividing fractions, you do not need a common denominator, and getting one is a complete waste of time. So don't. All right. What's the LCD of 2x and 15?
30x.
All right. So I've got to multiply this by what? 15, and this becomes 75, and this 2x, and this becomes 8x squared. So we get 8x squared plus 75 over 30x. I can't factor anything out of the numerator, so that's my final answer. Okay. The second problem, the multiplication, 5 over 15 is 1 over 3. That's supposed to be a 1. 4x over 2x is just 2. And my final answer is 2/3. So very different depending on the operation, huh?
Yes.
What if you went in for plastic surgery and you wanted to have a tummy tuck, whatever that is, and instead they clipped your ears? Ugh, you look like a Vulcan. What's that?
I don't know how they'd make that mistake between your stomach and your ears, but
You don't think they do that? My point is, if you use the wrong operation, things could be devastating. You'd look like Spock the rest of your life. Oh, well, not that that's necessarily a bad thing, especially if you're Vulcan, right? Okay. That's all I have to torture you with today. I will be back this afternoon at 1:15 with an office hour. Should you have need of me, have a great rest of the day. And